My name is Mac Binesh. I'm the Group Product Manager at the Enterprise User Computing Division, essentially the VDI, and my group basically publishes all the reference architectures for VDI on our website. Ours, as well as the ones we do, our primary partners, such as NetApp and Dell and HP, EMC and VCE. So today we have a very good agenda for you with a specific case study with one of our largest customers in the UK. But before I get into that, I wanted to do a couple mandatory slides that we're going to take care of. You've probably seen this. I can wait till you finish reading it. But I imagine you've seen this several times, so let's just move on. This is essentially our journey to cloud. It comes in 3 stages, taking IT into making it as a service. And essentially, you start out with virtualizing, workloads that are with load governance, and then you slowly become more agile and be able to enhance the communication among the IT as well as the business units and line of businesses by starting to virtualizing more of a tier applications, second, 2-tier and 3-tier applications, at which point you become more agile and dynamic in your executions. I'm just going to move on to our agenda now. We very glad to have our customer CBRE here today to present to you their adoption of our View architecture in their environment with a very large user base throughout EMEA. And that's going to about a year ago, we announced View 4.5, and we had a lot of feedbacks. And primary features in that product were essentially tiered storage and floating desktops, stateless architecture. It's been a year since we published that, and a lot of people are asking us and give us feedback of who's actually using this, who's adopting it. And today we're actually going to present you the case study for CBRE based on the architecture we announced and based on the 2 attributes that I mentioned that came with View 4.5 that are specific to View with vSphere. We also have a test result study that we did based on a workload that we normally use to publish our VDI workloads at scale. And some of you may be familiar with the workload called ROC. And essentially, it simulates users using horizontal applications such as Office, PowerPoint, and so forth. And a lot of people were asking, well, how would this workload affect the durability and write amplification when using SSD in our architecture? If you remember last year, we built an architecture called Stateless Desktop on local SSD that reduced the CapEx and enhanced the user performance and experience because the increased amount of IOPS that are available and normalizes the boot storms, and you don't have to size for that stage of VDI deployment. And people were wondering, well, how does that affect when you do recompose, when you do a lot of deletes? What's the right amplification doing that type of workload? And we actually have done a study in conjunction with Intel, because those are Intel SSDs that we used at that time. And Intel analyzed the data for those 2 use cases that I mentioned, and we'll present you the results of that data today, and you'll be pleasantly surprised. So before I get into the presentation, our division announced a solution program called VRDS. This is Virtualization Ready Desktop Solutions, which basically, this is the website, and there's a lot of content there. It provides a architecture, if you will, to certify various solutions proposed by our partners that would basically have the entire stack built into it and ready to go and validate it. Some of them to name would be Follow Me Desktop, for example, or Single Sign-On with Improvada, or remote employee workers in federal government. So it pertains to a lot of the vertical solutions that we're publishing, and this program will be a vehicle to actually certify and validate and publish those type of architectures. And I encourage you to visit the website, and you'll see there will be more and more of these solutions being published and validated. It will help you actually reduce the POC process, as well as be able to deploy them with confidence that they have been validated. All right, so a question. How many of you, with a show of hands, actually know what the stateless desktop is from a year ago? Okay, very good. Well, the term stateless was actually introduced in our VMware release, and essentially pertains to floating desktops. We call it floating because it essentially is it's a reusable pool. And the user logs in, they get a desktop out of the pool, and basically, your user can make all kinds of changes to it, but once they log off, it gets refreshed and the image gets destroyed. So it's basically a pool that everybody can log in and use, and it addresses a lot of different use cases, which one of them is to reduce the cost of the desktop, as well as provide a tiered capability to separate the base image from the persistent data, persona management, or the application itself. I'm just curious, how many of you actually deploying VDIs with either a stateless or persistent type desktops? How many do persistent? Okay. And how many do floating type pools today? All right. So it's interesting because we think the market started out with a lot of persistent, because that allows you to easily allow user to install applications. It has the same experience as you normally have with your laptops, and be able to manage it just like another desktop through an IP address. But we think the market is moving toward adopting stateless and floating desktops as you get the tier capability in your environment. So the storage tiering is really a feature that was also unique to VMware 5. It takes advantage of capabilities through vSphere and Virtual Center. And what essentially allows you to do is to have SSD or faster type drives where you can actually deploy your replica during the boot storm to get a higher IOPS. And as you know, the read-writes changes from a boot storm to a steady state from a 90 to 10% to 50-50 read-write ratios. And traditionally, the sizing of the architecture has been, to address the boot storm, which basically, once the user logs in, you don't need so much capacity in IOPS to be able to address the user logons and addressing the issue with high reads. A typical Win 7, when it's optimized, you could expect to see about almost 100 IOPS during boot storm. But once you start getting to steady state, it could drop down based on a workload to somewhere around 10 to 12 IOPS, depending on the application footprint. So sizing becomes an issue, which affects your CapEx, which affects your infrastructure cost, and pricing per VM, which is one of the pillars in building a balanced reference architecture, in addition to user experience as well as scalability and density, VM per core, if you will. So tiered storage is a unique feature also within View Composer. It was introduced a year ago. So these two features really enabled us to build this type of architecture, and that's what you'll see how the adoption was. There are many ways to adopt this, and that's the flavor that we're going to show you today. Essentially, if you play around with stateless desktop and floating pools, the interaction is the user just logs in, they get a fresh desktop from the common pool, and once they log off, it gets refreshed. And from an IT's perspective, essentially they're managing and entitling users to these pools, and they be able to they do the provisioning. They can basically create the pools ahead of time. Desktop could be booted ahead of time and ready to go. Some of the benefits you'll see with this architecture is that from a user standpoint, they'll get a faster logons, because now you have a tier capability. You're not going through the entire process of competing with 300 or 1,000 other concurrent sessions trying to get your desktop booted and logged into. You get a better user experience, and And of course, from an IT perspective, they can lower the CapEx, and also from an OpEx standpoint, they can reduce the amount of patch Tuesdays or other things they would have to go through, because now you have a lot more IOPS at disposable, both read and write, and be able to patch things much quicker rather than come in at 2 a.m. and try and be ready by 8 a.m. on Tuesdays. So there's a lot of benefits to be able to have these two features in your environment. So the use cases that we addressed when we published this reference architecture, we dealt with task workers, anywhere from 2 IOPS to about 10 to 12 IOPS, kind of range workload. But as you see today, there's actually a mix of persistent and non-persistent type pools deployed in the similar architecture in our case study. So I'd like to introduce Roy Clements, who's the view architect at CBRE, and he'll go through the use case.
Thanks, mate.
Welcome.
Morning, guys. So, oh, that's the wrong way. Good start. And there's no pressure either, because my boss is in the front row as well. So, basically, I wanted to just talk to you guys today about how we've taken the VMware reference architecture and made modifications to make it fit our business model, and where we've been successful, and also where there's been a few, pitfalls, and where to kind of, the problem areas that you guys need to look at when you're doing your rollouts. So CBRE, they're one of the largest commercial real estate firms in the world, and specifically my leg, which I work in, is the EMEA part of the organisation. So we have about 5,000 employees and about 6,000 desktops across about 134 offices, as per there. So the actual topology of the organisation is pretty diverse. We've got 2 kind of like main locations in the UK and remote offices around EMEA as well. As we've rolled out the solutions, I'll take you through here a little history lesson as to where we've been with View so far. So CBRE have been a really early adopter of virtual desktop. So I think it was around September 2008. We did a proof of concept with VDM2, 1 desktop in there, and I think the guys had a fire in one of the Prague offices, and then overnight they provisioned kind of 35 fat desktops for these guys to work on. So a pretty quick, rough and ready validation of the actual infrastructure and how it works. So based on that success, it's all going to be great. Went to Abu Dhabi and Dubai, tried to roll it out, and it didn't work, because RDP just doesn't work on kind of high latency at networks. There's a few shaking heads in the audience have obviously been through that pain as well. So around that kind of November time, we went up to VDM 2.1 and started surveying the EMEA sites for suitability, so places with fairly decent network connections, not ludicrous latencies, things like that. Went to VDM 3 around May time and deployed to 100 users in Poland, so with a new MPLS network that we had there as well, so RDP based still in there, but that was pretty successful. And again, for that kind of limited use case, very specific kind of workload, that worked very well. June 2009, went up to View 4 and started to actually migrate the previous environment onto this new platform, so finally turned off the actual VDM2 original POC, sometime that year, and 200 new users on that system as well. So what we found here when we went to View 4 is, we were still we were using link clones, but looking at our actual image and the way we do things like antivirus and the way the apps are delivered, all had to kind of change, because we got to about 335 users and we just couldn't scale. So we couldn't get the performance out of those virtual machines. So, there was storage IOPS and network, and the way the image was pretty bloated and had problems. So about July 2010, an attractive British engineer joined the company, and we sort of started to look at the actual VMware View 5 architecture, and we decided to take it from scratch and take a kind of, solution-led approach to actually sit down and design this from the ground up. So it's about this time when we spoke to Mac and the team to actually, get the reference architecture out and start looking at how we can take that and adapt it into our environment. So we built the View 5 architecture. We looked at the LAN, the WAN. We did all the kind of due diligence around, quality of service, class of service, spoke to Teradici, VMware to get, proper network statistics, looked at the actual image and how we can do things there. So what I'll go into in a minute is how we architect it, but this is sort of how it's scaled. From July last year is how we are. So by August, we had the first cluster up and 600 users on. Successful, good performance, every single user, fast login time, fast apps. By September, we'd done the first one and now had to roll out the next stage of it. 500 users in by October. Then by December, 1,000 users. And by February, we had the first cluster pretty much nearly complete. And as we are in April this year, we've got the environment fully up and another environment up for DR. So using this kind of architecture, we were able to really, really rapidly scale the solution. So previously where we'd hit brick walls, this is a really good way of being able to take the technology and ramp it out fast. So we had a pretty aggressive rollout scale, but you guys some of you guys will have, some of you won't. But for us, we had to roll it out fast. So we've got 2,000 users in prod right now, and we're just about to look at the next stage of what we're going to do. So we'll talk about that a bit at the end, and if we have some questions there too. So just to talk about what our users do, so we've got a pretty diverse set across the whole business of what these guys do. So we've got surveyors, we've got people in finance, HR. Our policy is to basically give everybody a virtual desktop. We're going to be all things to all men, and we want everybody to have good performance. So we're not just kind of picking a certain set of applications, we're giving them everything. And the spec, the kind of remit that we had is that really it's got to be better than physical. So it's got to be quicker, it's got to be more reliable, it's got to be accessible everywhere. And we kind of went from the top down by giving the initial pilot virtual desktops to like our C-level guys and those chaps. So probably the most harshest critics of anything. So once they're convinced, obviously everybody underneath them gets a virtual desktop because they say, hey, it works for me. So we looked at about 80%, probably over 80% of our users were heavy users. So the Rorke tool has a category for that, but pretty much everybody crunches a lot of data, does a lot of spreadsheet, document template creation, PDFs, images from surveyors, Google Maps. Don't get me started on Google Maps and how heavily that's used in there as well. Didn't even realise that our surveyors would use that as opposed to actually visiting somewhere. So that's another performance point that we had to look at as well. Office pretty much heaviest, Outlook of course, everyone's in that all the time, but mainly kind of report-based stuff and images. But we've got guys using CAD as well out there, AutoCAD, and other graphically intense content creation roles as well. And we've got about 150 apps in all across the whole business. So one of the first things we did was to actually set off an endeavour to thin app or virtualise all of the applications that we could. So at the moment, the only thing that we put in our image is Microsoft Office, because obviously everybody uses it, but everything else is thin apps. And that is something that's probably overlooked a bit in most people's kind of deployments, in that that's probably a really critical thing that you should do first, or spend a lot of time and effort doing first. And seeing the things that are here today, like Thin App Factory and the stuff that can make that a lot easier for you, that's something that you really want to look at first. The users also generally roam a lot between offices. We had a lot of laptop users, but they tended to just go from office to office. We do have some remote workers as well out there, but mainly kind of, maybe 25-30% of people are roaming. And we've also got lots of people using mobile devices like, iPads, iPhones, like you saw today. So, and we actively encourage those guys to access their VDI desktops on those devices, because really it's a good PR exercise for us, and it gives them an incentive to do it as well. So we designed the platform, as we were saying, sort of with a few kind of differences to the actual reference architecture. So we looked at the ref architecture for Stateless specifically, and for the standard reference architecture, and took a kind of homogenized version of that for our architecture. As Mac was saying, we've got our first iteration, and still the majority of our users that we have in production are persistent desktops, simply because of the way the organisation works and the speed at which we rolled everybody out. But we're now looking to try and move everybody now onto a stateless desktop, so Win7 stateless desktop. Because the problem with persistent desktops is that you still have to support those guys as if it's their physical PC. So if a user has a problem, I've just knackered my install of Adobe Reader or something like that, a help desk guy has to look at that VM or provision him a new VM. Whereas stateless, you can just log out, log back in. So there's some things to look around there around, user profile management, if you're going to use it. We don't. We use Active Directory roaming profiles. And we want to use we are using the View 5 persona management pieces in there as well to roam particular bits. So things like Outlook OST files. Who uses Outlook in the video? Everybody, right? So Outlook OST files can't be roamed to the network officially. So if you have, if you don't have the capacity to put everybody on online mode, you've got to have a persistent disk with the user data disk. So we're also migrating to things like Exchange 2010 to allow us to do stateless. So there's external things around that environment that you guys have to look at as well. So we broke down the kind of platform design into these bits. So it's cluster architecture, view architecture, and desktop blueprint, which we'll go through now. So the vCenter design, is part of the reference architecture is that it's one vCenter managing 2,000 objects in the cluster. So you guys are probably all familiar with this. It's 8 hosts per cluster, which is View Composer limitation, and we have 80 virtual machines per host. So we go drive it very aggressively and try and have as maximum density as we can. With the improvements in memory and like the cost going down again, we can squeeze that further as well. What we use at the moment in our production cluster is we use HP DL360s, so fairly basic commodity servers, diskless, ESXi, 96 gig of RAM, and 2 4-way Nehalems in there. And that gives us plenty of capacity. And that gives us enough for 80 virtual desktops and a couple of virtual appliances on there as well. So one of the things that we did that was different is we looked at one of the kind of big hitters that was giving us performance problems in the virtual machines, and it was our antivirus. So AV, no matter how much you stripped it down, the read-on-access scanner was really caning the performance of those boxes. So we looked straight away at the vShield endpoint solution and the Trend Micro Deep Security Manager. So we looked at that, trialed that, it worked, and it took a huge overhead out of the VMs, probably about a 40% drop in disk I/O off those machines just by removing that one part. So we took that out, and that's what we use in prod. So there's solutions from other companies like Sophos and McAfee have got them as well, but at the time, Trend was the only one that was kind of production ready. So we deployed on that. So it's vShield endpoint with that, and that gives us a bit of an advantage there as well. And there's the penalty for that is that you have an appliance that sits on the ESX host, but we've got a little bit of overhead in there. 8 node clusters and about six. It's probably a bit less than 640 desktops in a cluster, sort of like a nominal load there. And then the cluster groups up into three lots of 8. If anyone's seen the architecture before, it's all kind of old news to you. And that then becomes a pod which supports our 2,000 users. There's a screenshot from my virtual center. I promise I didn't turn any alarms off as well, so I've got a red one there on 22. So that's in there. And that's what our environment looks like today. Just say View 4.5 or View 5, this slide, which I actually stole from another VMware presentation, so I should have done a Visio. Apologies for that. But View 5 scales in exactly the same way. There's no scalability changes. This architecture remains the same for View 5 as well. So you have 3 clusters in a block, and then you have the brokers managed in the same way. So 5 brokers for 10,000 connections. Our VMs at the moment look like this. So we've got XP with a gig and an 8 gig OS drive and an 8 gig user data disk, or persistent disk as you call it now. And that is mainly to accommodate for our Outlook users who need OSTs. The Win7 VMs have got 1.5 gigs and a 24 gig OS, but no persistent disk. But there's some technologies that we use in here that kind of make that not a problem anyway, really. So the way I split the desktop, or the way the guys split the desktop up is like this. So it's comprised of these kind of 4 discrete components that becomes a user's desktop. So I have an OS disk and core apps installed on there, which is on an NFS data store presented by an Atlantis Ilio appliance. So the guys are here, and you can go and have a look. They basically have a way of looping back storage through to an ESX host and caching and accelerating it, single instancing it, and doing in-flight dedupe and things like that. So that appliance could go on to, in our case, we use Fibre Channel. I'll explain in a minute how it works. But we use it on our SAN, so we present SAN storage to it and accelerate that. You could use this with SSD, or you could use it with local disk or whatever. So it's quite flexible. With tiered storage, which is allowing us to do this, is what kind of gives you the flexibility here. So we put the OS disk on a shared replica across all hosts. And then we have a OS disk, which is on a locally attached accelerated volume as well. So we split the kind of read and write operations out. So the read goes to a kind of top-of-rack appliance, and the write goes to a local appliance on every ESX host. I'll explain how that works in a minute. And we've got our thin apps, which are on a DFS share in Active Directory, and just on group memberships are streamed into the user's desktop. So if you're a member of a group, you get the app. And we do that, and we've pretty much virtualized nearly every single application that we need now as well. So that gives us quite a bit of flexibility around how we're going to provision. And of course, migrating to Win7 thin app means I don't have to regression test all my applications. So most of them are going to work straight out of the box on Win7 without too much tweaking. And then we use redirected data again, which goes off to DFS. So profile data, like internet favorite settings, things like that. So talking about how we use the kind of accelerated storage architecture, we use an Atlantis Ilio appliance. So you'd have a VDI host with with Fibre Channel attached storage, which we have. and I put a little appliance on my server. It's something with like 16 gig of RAM, 2 CPUs. And then I basically present it a disk, and it exports that as an NFS share, which I then loop back into that same ESX host. So it's pretty easy. So it just shows up as another data store on my host. But because it's kind of looping through the appliance, it's accelerated, single-instanced, and deduped. So it's basically sitting there with an enormous cache in front of my I/O. So anything like a big write storm or a big boot storm, it's basically read from the appliance rather than having to go back to the disk. So I get like a really nice smooth curve of performance. So whether I've got 1 user or 80 users on that host, the performance is the same. And on the read side, we do the same thing. So that's a host with a local cache, and we just add a read cache on there too. And it's split up across these two sides. So my replica disk lives on there, and my OS disk lives on the local storage in there too. But as far as ESX is concerned, they're just a couple of NFS shares. So talking about the ref architecture, this could be local SSD stores. It could be any other kind of appliance that you use to accelerate that. And this is how it looks in the view architecture as well. So there's a screen grab of one of my desktop pools in there, and that just shows that the replica disk is sitting on that read cache store there, which is an NFS type store, and the write cache goes off as well on the same thing. In this case, actually, the OS disk is on just a standard fiber channel. So, you can mix this up and chop it up however you want to do it. Some performance data from here then. Interestingly, when we're talking about what the kind of read and write ratios are, and the deployments that we've done, I've seen that, I think like initially VMware said that it was something like 80-20, 80% read, 20% write. But I think in reality, and what we see, it's probably more like 60% write, 30% read, is what you see in most instances. And that's across stateless and state. So it can be around 50-50, but I think with the Rorke tool and with the stuff that the guys are going to show you, it's slightly more write heavy in a real world environment. So you see there, for one cluster, you're sort of driving, on the read side, you've got 2.7 or 2.8 MIPS, and then on the write side, you've got, whatever that is, 6, 7. So, a couple of orders of magnitude bigger. And for the pod is the same. So overall, it's more write heavy. So we took the decision, based on that testing, to isolate the write traffic per ESX host. Some protocol performance data, just to chuck in here, because it's a good stat. I kind of did this on one of the afternoons where I only had 900 people connected. But we use Zangati, which I don't know if many of you guys have seen here. Zangati is a performance management tool that you can have, and it'll actually allow you to view, analyze traffic, report, things like that. So I pulled up a Zangati report of just my PC over IP traffic for the whole data center. So we had total outbound PC over IP traffic, which is about 100 meg, and 900 concurrent connections, and about 111 kilobits per user. So we see that, I actually see probably a little bit higher than that, probably between 150 and 180 kilobits per user average across the whole organization. So it's probably quite a good stat, to have a look, because that is an honest real-world statistic of what PC over IP usage actually is. And this was actually on View 4.6 without any of the protocol enhancements that are in 5. So I'm hoping to see an improvement there as well. And that's it. So we'll have some questions at the end. So I think the next one, chap, was Alex to come and have a chat to you about some performance workloads. Please.
Hi, my name is Alex Kobuziatsky, VMware, working on reference architecture with Mac. I will show you some very interesting result. We conduct test on Intel SSD based on some feedback from you guys. We're using consumer-grade SSD, third generation, 3020 series Intel SSD. This test was done with help from Intel. Intel provide SSDs tools to collect smart attributes in final analyze. Sorry. Okay. Okay. Before I will go deep in testing, I just would like to tell you guys our test environment. It's Dell R710 vSphere-based server, 192 gigabyte of memory, dual 6-core Xeon 5675, 2 Intel 3020s in RAID 1 configuration for redundancy. Goal of this test to test durability, write amplification, and reliability of local SSDs. We deploy 76 link-clone VMs using View. Smart attributes, what we use is MediaWare indicator. We collect data, how it was conducted this test. We collect data before and after. We use ROC tools, and also we use multiple time we recompose our pool multiple times. It's like almost like torture to local disks. We ran this test for almost a month. It's 22 days to be exact. Almost 550 hours. We collect MediaWare read-write. It's E3 read-write ratio and workload timer. During this time, like I said, almost 450 hours, 22. And after we collect all this data, we provide data to Intel for final analysis. And what we find out about durability, if you using Intel consumer-grade MLS SSDs, it will in View enterprise environment, durability, years of wear, what Intel provided, 6.22 years. Usually a cycle of hardware is like 3 years. We have 6.22 years, but it's excellent numbers. Also, another analyzed number what I would like for you to take a look, it's write amplification. It's 1.67. It's also related. These two numbers, it's correlate because when you have a bigger number, write amplification, it's less durability and years of wear. Some databases they have like 40 write amplification number. 1.6 it's a really a good number for this test, and it's like I said, it was like torture for drives. We use recompose many times, 80 link-clone VMs. It was really it's like torture because in most environment you will never have this kind of testing. We recompose almost every couple hours during all this time, and also we use ROC tool. numbers, I can. You have numbers. It's hours, 445 hours. Time, MediaWare, and all these numbers. What it's excellent number for Intel consumer rate SSD. Its model number. We use Generation 3 Intel 320s. Again, it's ours model with its numbers before test and after. This final analysis was provided by Intel. And again, life expectancy with this kind of load, it's more than 6 years. But it's really good number.
All right. Thank you, Alex. Thank you, Alex. I think I want to open it to Q&A session of any of the segments that we covered today. Rory, if you may want to come stage in case a question for you. So any questions from either of the segments that was presented today? Yes. That's a good question. So yes, with the storage APIs now, we're actually offloading a lot of these capabilities to the particular storage vendor, for example, NetApp or EMC or the others. EMC absolutely has a feature called Fast and Fast Cache, which automatically does tiering. So it depends on how you want to deploy this, because traditionally when you deploy VDIs, you think there's going to be a 60-40 read-write ratio, but 6 months later, after you do a lot of short strokes and stuff, your read-write ratio could change. And of course, the user workload and characteristics changes as well, so the whole design starts slowing down. So in some cases, if you have a lot of unpredictable read-write ratios over time, auto tiering might be a way to go. But you have to balance that against the amount of the cost of the overall architecture. So it has to be a balanced architecture, because in one case, you would have EFDs, not SSDs, enterprise flash drives, which they basically pulled around together. And I think there's like first 6 drives essentially will be dedicated to moving the high I/O blocks into that area, regardless of what kind of workload you're running into. And that works fine, but the durability of those drives are much higher. They're 5-year, enterprise level, 5 nines, but the cost is also a lot higher. So the overall architecture will cost you more, and your ROI may change because the number of VMs that you have to deploy in order to lower the cost. So it depends which way you want to go. If it's a task worker and low-end worker, you have capability to use View and create this auto tiering yourself by dedicating certain number of SSDs or low-cost flash drive to do what we talked about. So they're both similar approaches in terms of using the tiering capability, and pretty soon you'll see that there will be even more integration between View and vSphere as well as the storage vendors in future releases that you'll see next year. So there's a constant enhancement in that. But today you have 2 choices to do this. Absolutely.
Yeah. On the connection brokers, so we use a Cisco ACE at the moment, layer 7 load balancer. So it's just set up using that. There is actually a ref architecture that Cisco published for doing that as well. So we use ACE. We originally used Windows NLB. Obviously, it's not supported, but it works. But so when we went sort of large, we decided to use a proper layer 7 load balancer in there. Depends. So in our case, we're because we're using single instancing. With the Atlantis cache device, I can drive quite a lot more VMs on there, but the general ref architecture is 128, I think. If you're not using anything, Flash, it's 128 with one replica per store, right?
Yeah, correct. The best practice with vSphere mode is 128, but that's essentially because of SCSI reservation. And if you go to tier mode, you can actually, we've seen, with EMC, for example, Flash EFD drives, they've reached almost 1,000 because of high I/O capacity. So the best practice was really put in place several years ago, by the field. But those numbers are actually changing because the storage architecture is changing as well. So it used to be 64 VM per data store in the past before vSphere mode. In vSphere mode, it's 128. But again, there are published reference architecture on our website from EMC. If you choose to go that route, it can go up as high as 1,000, we've seen.
Your bandwidth for some of your sites with a lot of users, I think you mentioned Prague or one of the ones
yeah.
100 users. So what's your average bandwidth?
So we have a remote site in Manchester, as a good example. That's about 80 users, and they're on a 10 meg MPLS circuit. And they utilize that. We reserve, using QoS and COS, about 7 megs for PC over IP. But again, we see about 150 a good number is about 150 for general. But you do need to give PC over IP a bit of burst headroom as well. But we do that by guaranteeing it a certain amount of bandwidth. But so it's pretty good. I think field testing as time goes on, it's more and more, it's very, very kind of applicable to real world. It's not like kind of incredibly bandwidth hungry or anything like that, really. Yeah, so we've got some guys, we actually use, I forgot to mention it actually, but we actually use Samsung Zero clients for the actual desktop end device. So the majority of our users have them, and they're kind of like a 24-inch widescreen. So, there's very few people who've actually got multi-monitors because of that. But we still have a few guys doing that. And yeah, so we support a very small percentage of guys who have that.
Yes?
We're not. So no, we have for Windows event logs for the actual VMs. No, yeah, so we don't do that really. We do Zangati management of ESX side and real-time monitoring of all the ESX stats, all the protocol stats, network, net flows, things like that. So because we pretty much try and have most of the applications thin-out. Really, if there's a case where someone says, I've got a device, we try very, very few kind of incidents of sort of like, something that would pop up in a Windows event log like, I don't know, like a DLL problem or something like that, So, because the support approach really is, as quick as, resolve it as fast as possible. That's true, yeah. So, if you have, we tend to do that when we're doing packaging or problems, we do that in the kind of lab environment where we can say, well, this isn't working because of X, Y, Z, and we take it apart and try and do it. But you mean forensic from a security perspective? Or right, okay, yeah. So we use, because the View connection broker actually logs all the security events for us at login. So the authentication mechanism for everybody is through the broker, which is Active Directory, and then all the actual events that come through that are logged into a central events database, which is all just built in with VMware View. And that does security log auditing and goes for, but you can turn that up to be as kind of detailed as you like. But default setting is all the kind of stuff about, unsuccessful password tries, requesting desktops that aren't available, or, incorrect login attempts, account lockouts, things like that. So for us, it may be that in a more secure environment, maybe like, commercial trading or something like that, you might need a higher level of auditing and reporting on there. But for us at the moment, we just use the out-of-the-box tools that's there. Oh, yeah, sorry, mate. Yeah. Yep. Yeah. No, so we have, basically, we have 96 gigs to kind of guarantee a gig of physical memory to each, in this case, XP machine that we have there. So the Win 7 we give 1.5 gigs. So, yeah, we're looking, at the moment, we're kind of probably 30%, deployed there. At 1.5 gig, we're getting pretty good performance, but there's going to be slightly more memory overhead there as well. But there are some tweaks that you can use. There's some VMware knowledge base tweaks actually about the amount of system memory that ESX takes by default, and there's also some CPU scheduler performance tweaks that you can do as well to change the fairness algorithm, so it's a bit kind of like more biased towards a desktop workload. Oh, no, well, there's tweak. No, so they've got their normal Nehalem, kind of standard set. So there are tweaks that we do in the build to do with like NUMA page sharing and things like that as well. So that's actually an ESX configuration option that you can set. You can tell it to share pages across NUMA nodes. By default, it won't because of the performance. But in a VDI environment, in a desktop workload environment, you can take the performance hit and get the extra kind of sharing that you get with allowing to go across NUMA nodes there. Yeah, it's actually in a it's in a vCenter white paper. It's in a vCenter performance white paper, and so to be honest, it's not kind of widely published. But again, it's it's one of those things you find it and you recommend it. So yeah, I mean, if we get offline, I can point you in the right direction. No worries.
There's one related comment I want to make. Sorry, in terms of overcommit, potentially that could be another consideration. We've been asked that question many times. What are the best practices for overcommit? How much do I overcommit? The best answer that we have, the best thing we've seen as best practices is watch your CPU utilization and try not to go over 70 to 75%. That's really because it's all relative to how the workload behaves, how much memory you have, and so forth and so on. But that's essentially the best practice. So you have enough headrooms in case if there's a failover. Otherwise, the VMs won't start up. That's essentially what you end up with. There was a question here on this side, I think, earlier. Someone raised their hand.
You can't have more than 5, I think, is the best practice. So
that's correct. Yeah. The architecture is a 5+2.
5+2.
And 2,000 connections or authentications per broker. So that gives you a 10,000 number.
Yeah, 10,000.
But it doesn't mean you have to deploy that much because you're essentially aligning the pool sizes with that. And the pool size, it's a 512. It's going to be higher later on, but it's 512. So that plays into the management of the pools and so forth. So how you want to basically align the pool size to number of connection broker and how you want to balance those two items.
It depends. I mean, for PC over IP, the brokers are literally just doing authentication and then direct connection. So the broker says, yeah, Rory, your desktop's this, go connect to it, and then its kind of job is done. So best practice-wise, I mean, you want it to be as well connected as possible to where your infrastructure is, but there's no kind of hard and fast rules about where you would place them. If it was me, I would put them as close to my VMs as possible. But
typically, we have best practice documents published with F5 or any other load balancer that you can put in front of them. By default, the setting is set to secure, which means that you're in tunnel mode. When you authenticate, it actually goes back to the broker itself to get to the VM. But you can turn that off if you want. And basically, after you authenticate, the VM, the IP gets passed to the client, and now you get direct connection to that, which gives you an additional 30% less of an overhead in your connectivity because it's not secure anymore. But if you're in a LAN, you have defense in depth, and you don't worry about that.
Yeah, we use that internal only, I should say. There, yeah. Oh, yeah. That's a good question. Not putting me on the spot at all there. Well, I think we did it not so long ago, didn't we? 1,500. Well, I know 2,000. We did 2,000 in, I think it was about 3.5 hours, just under, when we had to build another environment and spin that up in the same way. So about 3. Provisioning a new virtual machine probably takes end-to-end 15 minutes, not even that maybe, yeah, something like that. And of course, that's just us at the moment. That is going to increase as time goes on with storage technology and things like that. But that's because it's provisioned, but then of course it's got to customize, join the domain, reboot itself, come back, get an IP address, and then say, hey, I'm ready. So there's that extra little bit at the end there. Yeah.
Are you streaming your ThinApps?
Yes. Yes, all ThinApps are on network share, as per this slide actually. They're all on the share, and just by groups are presented in that way. So we use the MSIs, and we also use the ThinReg method as well to give the shortcuts and all that sort of stuff. So a user just sees it in his start menu and it's streamed in.
There's a gentleman in the back.
Yeah, you're right. We didn't have our Exchange 2007 servers couldn't have handled 2,000 online MAPI connections, basically. So what we're actually doing is we move into 2010, where we're going to go fully online mode there, because the architecture is different. So you have the CAS array instead of hitting the mailbox servers. So But, that's just one of those things. It's, that's a tactical thing. I think most people who had 2007 probably went cache mode, for that exact reason. That's the whole reason it's there, is to get the load off your mailbox servers, isn't it? So that was really the only reason we couldn't go.
Yes?
There was another chat. Oh no, so it's just it's a distributed file. It's ADDFS. Well, we have a DFS store where our thin apps are, which is replicated around our organisation. So when I hit the shortcut, for my thin apps application, which could be AutoCAD, it just goes to my local DFS namespace and gets it there. Because we have other sites, we have other bits. Yeah, I just put it there just to, I fancy putting another acronym in there. Yeah. All right.
Question there.
That's a good question. Well, there's, I spoke about Google Maps. We are looking at the Teradici offload cards, which are coming. We're actually doing some performance testing for VMware because they've put a lot of optimizations into View 5, and it's got to the point where obviously, it's so optimized, how much more optimization can you do? So we're looking at that for things like 3D, Google Maps essentially kind of rendering and that particular content, because we did have some trouble with the way PC over IP displayed or the way the codec interpreted that behavior. Basically, it was really slow to load. So I think it was sending it as lossless. So there's a few things that have done. I think Google upgraded their back end, actually, which kind of solved the problem for us overnight, which was quite nice. But, things like that. And as more and more kind of rich content, is being used, like our kind of intranet is all Flash-based and lots of video. Everyone uses kind of high performance, Adobe creating high graphical content, rich content stuff. So we're going to look at, we'll look at the offload cards, also look at the software GPU stuff that's in vSphere 5 and View 5 as well. Simulating a 3D GPU, so you can do things like aeroglass and other effects. And I imagine it's probably going to be some incremental improvements that happen as time goes on, really. But because at the end of it, you just can't break the laws of physics with some of these things, so you have to, balance what you're doing there. Yeah. No, not on the tuned build. So there's a kind of an optimized VMware build of a Windows 7, which is a published document that they have, which is Win 7 guest customization guide or something. But there's like kind of basically when it's tuned down, it's pretty good. It's quite well. It's actually more well behaved memory wise than XP is, believe it or not. But you pay for it because it's a bit more heavy on IOs, so it kind of balances out. But no, I think the rule of thumb is you've got to allocate. If you're going to have 80 VMs with a gig, you've got to allocate. Really, if you want better than PC performance, you've got to give them a gig of physical RAM. Or whatever your allocation is has to be, there needs to be a physical bit there. You can overcommit a bit. What we see on each host with, say, 80 VMs on, we see probably 25% of those guys are actually really, really driving those VMs. The rest are just ticking over. So that's like the guys who've just got things sat there doing nothing. So there's swing room for them to kind of burst in and out if they need to. But I think, rule of thumb, you've got to give them the real resource. There's no way of compromising there, really. If you want the users to love you, not hate you.
Yeah, there's a follow-up to that. Win 7 optimization, that's a very good point. It's on our website at vmware.com/view technical resources. There's a document there, has a built-in script where for all changes to optimize, you can just run that on a Virgin Win 7 installation. And essentially what it does when we did our testing, it reduces all the read IOPS after the boot storm, because Win 7 itself is essentially paging back and forth after it boots. And that's what you want to get rid of to be able to enhance the performance for the other boots.
Yeah. Was there one around here somewhere? Was there a guy poked up behind the projector who wanted to ask a question? No? Oh, he's gone for lunch. No? That it?
Okay, we're early.
No more? Cool.
Thank you very much.
Thanks a lot, guys. Cheers.
Thanks, Rory.
No worries.
Well done.
Cheers, mate.
Yeah.